Hi everyone, welcome to another episode of Don't Be Average. In this video, I'm going to show 12 easy ways how you can handle missing values. Missing data is basically having blanks or no data available for some of the records in a data set. If you have such missing values in your data, then it becomes difficult to run machine learning algorithms or do any sort of data mining because many machine learning algorithms do not support missing values. Also, sometimes missing records impact the accuracy of the whole analysis. That is why it is very important to handle missing values in the data. So let's see how you can deal with missing values like an expert.
It's only worth it if you work for it. I won't stop till they hear me now. I won't stop till I wear the crown.
The very first and a very basic approach that we could take is deleting the row that has missing value. If you have less number of missing values and your total data size is large enough for your analysis, in that case you can remove the rows that have missing data. It's a very quick and dirty method that can be applied if you need to quickly analyze your data without having to handle its missing values. One good thing about this method, it's very easy to apply and it's very quick. In case you don't want to spend a lot of time in handling the missing values and go quickly into the results and you think that's not going to impact your analysis or the accuracy, you can go ahead with this approach. But the cons are, like I said, we are losing a lot of information. There's one missing value in one column because of which we are losing all the records in all the other columns for that row, and that's why it works only for smaller number of missing values and a huge data size. In case your data is small, only 100 records, and you have 30 missing values in one column, then you will end up removing 30% of the data for all the columns. That's not recommended. Next one is deleting the entire column that has missing values. Sometimes no information is better than incomplete information. So if you have too many missing values in the same column, then you can remove the whole column from analysis to avoid having incomplete data. This is another basic approach. It is only recommended for quick and dirty analysis and where you cannot spend a lot of time in missing value handling or any sort of data issue handling. I just want to jump into the results, and it's very easy to apply. It is very quick, and again at the same time we are losing a lot of information if we are removing the whole column, and in case that column was very relevant to the analysis, we are losing out on that. The third method is imputing missing values with mean. If you have missing values in a numeric column and you cannot afford to lose data by removing the entire row or column, then you can impute the missing value with the mean value of the whole column. Like here, we have missing value for 3 of the students, and we can replace it with the mean of the marks across the data set. Now, the pros of this method is there's no data loss. We are keeping all the rows and all the columns that were there in the original data set. But the cons are it only works on numeric data, and it doesn't work if there are outliers in the data. The fourth approach is imputing missing values with median. If you have outliers in your data, then the mean would become much higher than most of the marks, right? In that case, we should use median to impute missing value. Say, for example, in this data set, let's say hypothetically one person has 1000 as the mark, and we are trying to impute missing value in the marks column itself using mean. Then mean would be actually impacted by this extreme value 1000, and mean would come out to be 250. And if we impute all the missing values using a value 250, it won't be like a true representative of the whole population. So in such cases, we can use median. You can see median is 6 to 3, which is not impacted by outliers. So whenever you have a numeric data and you have outliers in your data, you have to impute missing values, you can use median. So here we have the median as 6 to 3, and we have imputed using the median. One good thing about this is again there's no data loss, and it also works on data sets with outliers. The cons are it only works on numeric data. So if you have categorical data, we cannot calculate mean or median. So these two methods will not apply there. Next approach is imputing missing values with mode. In case the column that is having missing values is a categorical column, in that case we won't be able to calculate its mean or its median. In that case, we can use the mode of those values to impute all the missing values. So here the mode of all the grades are B. So we are imputing the missing values for third and sixth row with this grade, which is B. Mode means the value which is more repetitive. So there's a high chance that the true data will also represent something like this. It is better than deleting the entire row and entire column, of course, but it is not recommended if there are too many missing values. If there are too many missing values, then probably the values that are existing are not going to represent the actual data in a very accurate manner. The next method is imputing missing values with a new category. Sometimes it is not very safe to impute a data set using mean, median, or something. Sometimes it is not recommended. Let's say even for this particular example, it is grades, and it is not very safe to impute one person's grade with other students. In those cases, we can just impute it using a new category, which could be called missing or not available or NA or something like that, which indicates that we do not have data for that, and we can go on with the rest of the analysis using this new category. This way, one good thing is it's obviously easy to implement, and also we are not adding any new information which may not be accurate, which may be risky. And one con is it actually adds a new feature which is probably not very true to what the data would have said, but it's less risky. The next method is last observation carried forward method. It's called LOCF. It's very popular. Let's say in your data set you have repeated measures per subject. Like in this case, we have repeated grades or exam dates for the same student, which is actually called longitudinal data as well. In these cases, we can use this approach where we are carrying forward the last observation. So here, if a student drops out of a study before it ends, then his or her last observed score on the dependent variable is used for all the subsequent observation points. This is called last observation carried forward method. Like here you can see the last seen grade for this student was B. That is what is being carried forward. This is better than removing all records for that student, of course. And the problem is it gets influenced by outliers. I'm going to show how that happens. Like in this example, we can see that the student got A grades throughout, but in the latest exam, somehow she got D grade, which is kind of an outlier. But if we try to apply LOCF method, even though she has got A throughout, she is a good performer. Just because in the latest exam she has got D, that is what is going to move forward. That is what is going to be imputed throughout for the all missing values. So here, what we can see is because of applying LOCF, the imputation that we get is kind of far from the reality, and her marks in this latest exam were actually outliers, because of which the LOCF method got impacted by that. And the same thing applies to the scenario if an average performer student accidentally gets very high marks in the latest exam, and scores in the next exams are imputed based on that exam. So two extreme scenarios can happen if there are outliers. So this method is not recommended if there could be outliers in the data. The next approach is interpolating missing values. It is also a good idea to interpolate the missing values using the rest of the values in the series. Now, interpolation means completing the chart. As you can see in this data, there's a gap between the numbers 67 and 71. If we try to complete the chart, probably we could find out what value could come up here. And interpolation could be happened using a line or using a curve. Based on which method, based on either we are using line or curve, we could get different values, but it will mostly try to connect the dots, and based on what value we get, we can fill in the missing value using the data points that fall in the line. Like here we have got 69. Now, one good thing about this, it's more accurate than forward or backward fill. It does not work well if the other values vary a lot. If there is no such significant pattern in the data, if we try to fill in the gap, it will probably lead to something which is incorrect. In Python, we have an inbuilt function called interpolate under pandas library. This imputes missing values by interpolating it and allows us to choose if we want polynomial, linear, or quadratic interpolation. The next approach is iterative imputer or regression. If the variable that has missing values is related to another column in the dataset, then we can impute the missing values using a regression model. Like in this data, we have name, age, and salary. If age and salary are related to each other, such that people with lower age are likely to have lower salary, in that case, the best way to impute missing values would be running a regression model of salary on age, and then predict the missing salary value by using regression model on their corresponding age. Now, one good thing about it is it's accurate, more accurate than forward backward fill, and always better than losing any information by removing rows or columns. But it does not work well if the underlying relationship is not very significant. If we are assuming there's a relationship between salary and age, but that if that is not true, that assumption is not significant, then it will fail. This is very easy to do in Python using iterative imputer function from scikit-learn library. The next approach is nearest neighbor imputation, which is KNN imputer. So let's say in this example, if salary column has missing values for 25 and tenure 2 years, this method will actually try to find the employees with the closest possible age and tenure, which is these two. And then it will take an average of their salaries. This is called k nearest neighbor imputation method. This is also supported in Python. In Python, we have a KNN imputer in sklearn library that can impute missing values using this method. Now, it's obviously more accurate than any descriptive approach like, imputing using mean, median. And but one drawback is it requires one or more columns that are correlated to the missing value column. The next approach is imputation using a deep learning library, DataVig. This method works very well with categorical, continuous, and non-numerical features. DataVig is a library that learns machine learning models using deep neural networks to impute missing values in the dataset. DataVig can take data frame and fit an imputation model for each column with missing values, with all other columns as inputs. This is a snippet of the code that we can use to apply this method using DataVig on Python. Now, one good thing about this is obviously it is very much accurate, and but the drawback is it may take a long time to run. Now, the last and final approach is using algorithms that support missing values. Some of the machine learning data mining algorithms support missing values. For example, k nearest neighbor algorithm, naive Bayes algorithm. These algorithms can be used when the dataset contains null or missing values. So we can fall back to these algorithms in case we don't want to handle missing values, or we cannot handle missing values. But the good thing about this is we don't have to handle missing values, of course, but it limits us to a certain data analysis approaches or algorithms. I'll wrap it up with saying every data is different, and before handling missing values, we should always understand the data. How the missing value columns are related to other columns, what is the data type of missing value, of course, what percentage of data is missing, this is very important. These things are going to actually help us find the appropriate method for missing value imputation. Hope this video helps you. Thank you so much for watching. See you next week. Till then, take care and don't be average.
Grab it, fuse like a magnet, lose won't have it till I'm doomed in a casket. I ain't playing, got a weird mind. If you work 8 hours, I'ma work 9. If the shit tastes sour, you should taste mine. I'ma stay in power for a long time. Get up, nah I ain't a quitter. Toss me the ball, I'm a really big hitter.